So far we have this simulation model, right? And then today we are going to develop more. So let's talk about the new modeling issues. So priority for seizing. So as I mentioned before, sales information, sales step actually seized by the sales division as well as the order status inquiry division, right? So let's prioritize the entities, actual incoming calls to seize the service step, okay? And in here, several places in the model request the same resource, and as I mentioned before. So these two actually departments actually request sales step. And seizing a sales step is not really hard, right? You can use process module or the seize module in advanced panel. And if you look at the sales information division, and here is the process module, right? Using sales step. And then also order status inquiry. So some of the 15% of the inquiry call actually want to talk with the sales step, right? With lower priority to see the sales step. All right, so in order to use the different priority, actually you need to go to the Q data module and then change the each type. So Q type in here is discipline basically, is the lowest attribute value. So sales call, you can create the actually property attribute known as sales call priority. So you need to specify this attribute in a assign module. And there are four types of priorities in Arena: first in, first out, last in, first out, lowest attribute value, highest attribute value. Okay. Also, if you want to use the one queue with the multiple modules, you need to choose a shared option. Got it? And lowest attribute means if let's say the attribute has four values, okay, and then entity with the certain attribute value, so such as 4, 3, 2, 1. So with the lowest attribute value, the lowest value has the highest priority. However, with this option, the highest value will have a highest priority. Okay. So you need to set a priority of an entity via assign module. So for the sales calls, you can actually set up the sales calls for the sales calls, a sales call priority with a value of 0, and then order sales for the order sales calls, a sales call priority with a value of 1. Okay, so you need to have a set order status call priority assign module. Okay, to set the attribute value. Don't worry too much about it. I will provide additional tutorials so then you can develop the simulation model with that tutorial. Okay, so also the priority process module. Let's talk about the priority of process module. So in process module, you can also set the different priorities. So lowest value has the highest priority usually. So you have a priority option here. And then priority rule is activated when entity in multiple process modules try to see the same resource. So you can also use a process module to see the same resource with different priorities. If all process modules have process module are using the same priority, you can choose the same option: medium, 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 or high, 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 or low, 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 and so on. So as a result, you will have this. You can complete this simulation model, okay, and then you can run. Now you are ready to run the simulation model to evaluate performance of the call center. Let's talk about another issue. So call arrival has a schedule right now. So this table show you the schedule of the calls, incoming calls, and then arrival rate particularly can vary over the day. So if you look at it during the morning time, we have a low actually arrival rate. However, during from 10:30 until 3:30, it's a kind of high arrival rate of the incoming calls. And then after that, still it is high, but after 4:30 p.m. and we have lower arrival rate of incoming calls. Okay, so this is the time around the noon actually is a peak time. This is our assumption. So we want to have a different schedule for the different step, okay? And so here we have sales staff of 6 people, right? So we have 6 people. We suggest this staggered schedule. So one person at the first 60 minutes during the first 60 minutes, and then 3 people during the second time slot, and then 4 people for 1.5 hours, and so on. Okay. Also, we have 11 people at the technical support department, and each person can work 8 hours a day plus, and then and also there is 30 minutes off for lunch. Yeah, it's kind of short lunch. Okay. And then however, some people are only qualified to handle the calls for a certain product type. So we have product type 1 to 3, right? So we have 3 product types, but certain person actually can only handle certain product types. Okay. And then some people are qualified to handle calls for multiple products, like 1 and 2, or product 1 and 2, or product 2 and 3, or product 1 to 3, and so on. Okay, or 1 and 3. So here's a technical support schedule. So you need to update your model based on this schedule. Okay. As you can see, we have 11 people right here. So 1, 2, 3, 6, 9, 11. We have 11 people, and then this first two people actually only can handle the first product type. However, Molly can handle the product 1 and 3, and Anna can handle the all 3 products. Also, Sammy can handle all 3 products, and so on. Okay, so you need to update the resource schedule based on this table. Okay, based on the information shown in this table. All right, and in order to implement these requirements, actually you need to utilize a Oliver schedule in Arena. So also this is known as a non-stationary Poisson process, because lambda value or Oliver rate can vary, right, over time. So lambda, actually in this case, actually we need to use a lambda t, right, at time t, right? So we have a non-stationary Poisson process. So let's look at the stationary Poisson process. So in this case, Olivers occurring one at a time are independent of one another. Okay, that's a stationary Poisson process. An average rate is constant over the time. That's why we used to use a lambda value. Okay, and then this one is what this if Oliver rate following the Poisson process, and definitely interval time between the entities should follow exponential distribution, right? With the fixed mean of lambda 1 over lambda. Okay, so however, for the non-stationary Poisson process, we cannot use this Poisson process property. Okay, but before you do that, let's look at the example. So in order to implement the non-stationary process, you may want to specify the arrival rate function over time, lambda t. Let's assume the following table represents the arrival rate of customer. Okay, we have 4 time slot, and then these are the arrival rate. And here we have 4 this is arrival time, inter-arrival time. Okay, between incoming calls or parts and so on. Okay, sorry. And if we have a higher arrival rate, and then definitely we will have a lower inter-arrival time. So if we can actually have 60 customers or incoming calls per hour, and then it is a customer, yes. So 60 customer during the hour, and then definitely inter-arrival time should be the mean of the interval time should be 1 minute, right? So you can divide 60 by 60 so that you can get the 1 minute right here. And if you divide 60 over 6 by 6, and then you can get 10 minutes like this. Okay, this is the lambda t, right? So yeah, let's assume that we have this table, and then there is potential problem actually. So if we let's assume that the entity arrival at t now over the 11:29 minutes, okay, 11:29 a.m. and then interval time actually following the exponential distribution with the minimum of 20 minutes, right? So 11:49. Right, so 29, yes, following this interval time, right? Okay. And let's assume that the next arrival has been scheduled after 33 minutes, like 12 2 at 12:02 p.m. Okay, in that case, we cannot actually consider. In this case, we cannot consider this actually the lambda t value from the 11:30 to noon, right? Because next event happened at 12:02 p.m., right? And then previous event was happened at 11:29 a.m. Okay, actually it's possible to have 33 minutes according to this distribution, right? This is the exponential distribution, so it's possible to have the value of 33 minutes as a time interval between the previous event and then current event, right? So in this case, actually you cannot generate any entity during this time slot, so you cannot really consider the characteristic of the last time interval during the last time interval from 11:30 to noon. Okay, that's a problem. That's a potential problem. Okay. However, we know that in this interval, there should be many entity arrivals, right? Because if our arrival rate during this interval is 60 per hour, right? 60 customers per hour. So we cannot ignore this area, actually this setting lambda value actually during this period. That's why you need to think about to use another like a technique to avoid this kind of potential problem. So why we have this kind of problem? Because the discrete event simulation actually generate the future event based on the current event. That's why. So you generate so Arena generate the next event based on the current event situation, right? So if we look at the table here, and then we can see that here is interval time actually between customer at this time period is very low. So it's possible to have a value of 33 or 40 is greater, which is greater than 30, right? Because it's following the exponential, this interlevel time actually following this exponential distribution. So it's possible to have that kind of high value. So that's why, that's why you need to think about another approach to avoid this kind of potential problem, right? We want to consider all the characteristic lambda t value for the different time slot time intervals, right? So that's why people use a thinning method to avoid this problem, to handle this problem. So first, for all period, you can so this method uses the maximum level rate. And in the above example, actually the maximum level rate is 1 minute, right? The 60 customers per hour, right? So interval time of that setting will be 1, right? Meaning for 1 minute. So you can use this rate for all 4 periods, and then second, disregard the appropriate portion in each period. Okay, that's what we call the reject or routine. So for example, in the schedule in Arena, initially we can calculate the max arrival rate and then get the minimum interval time, right? Like 1 minute, 1 minute, 1 minute, 1 minute. And then generate the entities or customer entities for each time period and then reject the unnecessary items. Okay, that's how we can consider all different lambda t over multiple time period. Got it? So here is the first column. First column is time, and then second column is the desired time interval level time. And we have seen this one, right, in previous table. And then if you find the minimum interval time from this table, this list, actually you can get the 1 minute, right, as a result. And then in order to meet this desired time interval, you have to reject 90% of the generated entities for the first time interval, and for the second, you need to reject 95% of the generated entities, right? And for the third, you can do the same thing, and then for the last, you can accept all the entities generated, right? So in Arena, create module actually use this thinning method to avoid that kind of potential problem associated with non-stationary process. Okay, let's look at the set module. So which help you form sets of resources, counters, tallies, and entities and entity pictures. And we have in set module you can have a resource set. So we can use a resource set for the text staff group. Okay, we text group. So to handle the calls for each product type. So for the product type 1, we have these steps, and then for type 2, for the product type 2, we have 5 actually steps, and then for product 3, we have 6 steps. Okay, steps. So here, once you have these 3 sets, and then you can utilize these 3 sets in Arena. So, and then especially you can assign the particular step in a set to call via process module. So when you click this resource and then click the add button, you can see this message box, right? And then here, when you select the set, and you can also choose the set name or previous set name if you already generate the resource set in through the set data module. Okay, in Arena. And then quantity, yes, we only need the incoming calls only needs 1 step, right? So you can put 1 here, and then you can choose different rules. In this case, you use a preferred order, and then that order will be the ID of the set, or ID of the resources in the set will be stored in this attribute. Got it? Yes. Also, you can generate a counter set. So in this example, we have a counter set to count the rejected calls by 1 hour period. So you can use aint internal function provided by Arena, which will truncate decimals towards 0. So aint 0.572 will give you 0, and aint 1.01 will give you 1, because t now can be a real number, right? So, however, in order to utilize a counting set, you need to have an index value, which is an integer. So you need to have you need to use a int function to get the index of the items in this counter set. Okay, so counters include different time period. Okay, which will have a number of rejected call for period 1, for period 2, for period 3, and so on. So initially you need to create the user specified statistics, okay, with this type. And once you have this type, and then you can actually create the counter set in send module. Okay, so in the record module you can utilize that set. Okay, and record module, once you call the set counter set, and then once you have a counter set, and basically you can actually, so here's a set name, and then you can specify the index to store the certain data to the previous to the existing statistics, user specified statistics. So in order to get the set index, so this is index 1, 2, 3, 4, right? So in order to get the index of the items in the counter set, you need to use a int function with the tnow. Okay, so look at this. So for the first period, I mean tnow value for the first period, first hour will be any value between 1 and 60, right? So 60 before the 60, I mean this value will be lower than 1 anyway, right? So for example, you can divide 95 over 60, right? Which is smaller than 1, and then by adding 1, you can have 1, right? So because the index is start from 1, so that's why you need to have 1 as a minimum value of the index. And then after that, you can, after first 60, and let's say after 1 hour, so first hour, like 9, when the simulation time is 9 a.m., and then each value will be 60, right? So 60 over 60 will give you 1, and then 1 plus 1 will be 2. So in the index value will be 2, right? Will become 2, so that all the entities leaving this rejected during this period from the 9 a.m. until the right before the 10 a.m. will be stored in this second statistic. Okay, right. So this is an overview of the model. So in addition to the previous modules, and then you can have a record module, right? A record module to save the information about the rejected call over the multiple time period. Okay. So in order to modifying the model, you need to open the model 5-1, which is a simple call center, and then go to schedule data module in basic process template and create a level schedule. Okay. So like this, based on the given table shown in the previous slide, right? And then also open the create call arrivals, and then change, and then select the type as a schedule, so that you can use a arrival schedule. Okay, here. And in order to schedule the resource, and then you can go to schedule data module in base process template, and then create the charity schedule and NOAA schedule and Molly schedule and so on. So you need to generate the 11 plus schedule for the sales staff, right? And then this data also, it was shown in the previous slide. Where was it? So right, this is the schedule, right, for the resource. Tech support, sales staff, right? Good. Right, and then open the create call or library. No, I'm sorry. And then in order to use the resource schedule, you can go to resource data module in the basic process template, and then select the charity or NOAA or Molly schedule, and then select the appropriate schedule. Okay, in the schedule data module. Okay, and in this example, we will use the ignore rule. Okay, for the schedule. And also, in order to use the set, user specified set, and you need to go to the set data module, and then in the basic process template, and then create the record set. Resource set, 3 resource set, and then product 1 should include this name, and then product 2 should include the name shown in the previous table. Where was it? So here's a table, right? So list of steps who can handle the certain proc type, right? So you need to have 1, 2, 3 sets, resource sets. Okay, and then also you need to generate the counter set in this same set data module in the basic process panel, and then member should include from the period 1 rejected calls. Should include period 1 rejected calls, period 2 rejected calls, and so on. Okay, up to period 10 rejected call, and these 10 user specified statistics are predefined, right? Predefined by you through the statistic module in advanced panel, right? Please look at the previous slide, especially when I already showed you this list, right? So here, under statistic, you have to define these statistics first, right? To generate the counter set. Okay, yes.